हेलो। ओके, आज का टॉपिक देखते हैं एप्टीट्यूड का टेस्ट फॉर डिविजिबिलिटी। ओके, तो आज अपन 4-5 टॉपिक कवर करने की कोशिश करेंगे। ओके, सो टेस्ट फॉर डिविजिबिलिटी देखा जाएगा सबसे पहले, फिर HCF LCM देखा जाएगा, कंप्लीट HCF LCM। ओके, कि फ्रैक्शंस के भी हम LCF HCM देखेंगे एंड लास्ट में हम देखेंगे कि कंटिन्यूटी काउंटिंग नंबर्स ऑफ जीरो। कोई नंबर आपको दे दिया जाता है और फिर बोला जाता है कि इसमें जीरो कितने हैं। ओके, और फैक्टर्स ऑफ कंपोजिट नंबर। ओके, वो भी एक टॉपिक टच करेंगे। ओके, सो लेट्स स्टार्ट करते हैं टेस्ट फॉर डिविजिबिलिटी से। सो अगर मेरे को कोई नंबर दिया हुआ है, सपोज लेट्स टेक, मेरे को एक नंबर दिया हुआ है, रैंडम नंबर ले लेते हैं 36। ओके, और अगर ये मुझसे पूछा जाए कि क्या ये नंबर, किसी एक पर्टिकुलर नंबर दे दिया, जैसे is it divisible by 9? Okay, so I know that it is divisible by 9. It's 4 times of 9. Okay, similarly certain numbers will be given to you and a specific value will be given, that is this number divisible by this number or not. So you have to be sure that this number is divisible or not. So how will you know that? So for each number, this number, we will focus on this number. Okay, there will be any number given in the exams and we have to know that which number, what is the properties of that number, like is it divisible by that number or not. Okay, so let's see one by one. So agar koi number diya, if a number is said or asked for to you that is it divisible by 2, so what should be the properties of a number which is divisible by 2. So if a number, if it is divisible by 2, so its unit digit, okay, the unit digit of that number should be divisible by 2. Okay, the unit digit should be divisible by 2, or this number can be 0 also, the unit digit. Okay, so if any one of the condition is true, if the unit digit is divisible by 2 or that number unit digit is 0, then we will say that हाँ भैया, this number is divisible by 2. Let's take one example. Suppose we have a number, just take simply 34. Okay, so the unit digit is 4. So divide this 4 with 2, and this is 2 times of 2 of course, so 0. So this is divisible, hence this 34 completely is divisible by 2. Let's take a bigger number. Suppose let's take 750. So unit digit contains 0. That means, yeah, the condition second is satisfied, that the unit digit is 0. Hence this number is divisible by 2. Okay. Let's see the condition for 3. So what is the condition for 3? Similarly, for a number to be divisible by 3, the unit digit, the last digit of that number should be divisible by 3. Okay, that's it. The unit digit, should be divisible by 3. Okay, this condition must be followed. Oh, sorry. Let me, sorry, just I messed up. Not for 3. For 3, just a mistake. For 3, the sum of the number, okay, the sum of all the digits of that number should be divisible by, this whole sum should be divisible by 3. Sorry. Okay, let's take one example. So if I have a number 132, suppose, okay, it's given and it's asked is it divisible by 3 or not. Okay, so I have to take this unit digits and add them. So 1 plus 3 plus 2. So what is the summation of this? This is 6. So I have to check if the summation is divisible by 3 or not. Okay, this is 2 times. Okay, so it is divisible. Okay, if we divide it, it is divisible. Okay, the end result is 0. Hence this number 132 is divisible by 3. Okay, next let's go to 4. So if you are being asked that if a number 4, if a number particular is divisible by 4 or not, so the condition is very simple. Till now we were taking the unit digit. Now we have to take the last 2 digits. Okay, the last two digits. Sorry, right now I am very unable to write on this tablet, but I will get quickly adjusted with this. So if this number, last two digit of that number is divisible by 4, that means this number, the given number, will be divisible by 4. Okay, let's take a bigger number, 864. Suppose I have this number and it is asked me in the question that is it divisible by 4. So I have to take this last two digit 64 and divide this 64 by 4 and check whether it is divisible by 4 or not. So let's check. 4 times is 2, 24, 6 times is 24. Okay, so completely this number is divisible, hence 186 is divisible by 4. Okay, so just mind what is the concept. Okay, the last two digits only you have to check. Oh, 1 second. Okay, so let's go to next section, divisibility by 5. Okay, this is very simple. Okay, so for any number to be divisible by 5, you have to just check one criteria, that the unit digit should be either 5 or 0. The unit digit should be either 5 or 0. If that's the condition, the number is divisible by 5. Suppose let's take an example, 75. So that unit digit contains 5. So it is divisible by 5. Let's take a bigger number, 790. So it is 0 in the end, hence it is divisible by 5. Okay, the two conditions should be fulfilled, like either it can be unit place can be 5 or 0. Okay, now for 6, same funda. 6, it's little tricky. You should know there are two conditions, both of them conditions should be satisfied. So what is the first condition? The number should be even. Okay, the first condition. Second, you have to take the sum of digits. Okay, sum of the digits. Okay, and check if the sum is divisible by 3. Okay, let me help you with this. So 6, what is it, is made of 2 and 3. Okay, just for remembering I am telling this. Okay, so it should have the properties of 2 as well as of 3. Okay, so 2 means like the number should be even, and for 3 what was the case, which I missed in this video, sorry, I said it little wrong. The sum should be of the digit should be divisible by 3, hence this 2, both the properties are there for the 6. Okay, so suppose if a number is given like 72. Okay, so you have, if it is asked that is it divisible by 6 or not, so you should know the both the condition. Firstly, check for even. So of course this is an even number, 72 is an even number, the last digit has 2 or 0. Okay, or divisible by 2, and the sum of the digits. So let's take the sum of 7 plus 2 is 9. Okay, and 9, check if 9 is divisible by 3. Yes, of course it is divisible by 3 times, hence this number satisfy both the condition, hence 72 is divisible by 6. Okay, so you should remember this two conditions. These are just nothing but the condition of 2 and 3, both are satisfied, that means it's divisible by 6. Okay, now divisibility by 8. Okay, so divisibility by 8, here you have to consider the last 3 digits of that number. Okay, what are the last 3 digits? You have to take that into account. Okay, you have to take that last 3 digits and perfectly divided with 8. And if the last 3 digits are divisible by 8, that means your number is divisible by 8. So let's take a big number, 93666. Okay, let's check for this. So take the last 3 digits, 366. Okay, let's check for divisibility with 8. So 8 4s are 32, and this is 46. So it is not divisible. Okay, so 8 6 are 48, 8 5s are 40. Okay, so clearly there is a remainder of 6. So this number is not divisible by 8 because the last 3 digit is not divisible by 8. That's why. Okay. for divisibility with 9. Okay, so for 9 it is very simple. The sum of the digits, sum of all the digits should be divisible by 9. Okay, okay, this is just the condition. So let's take a number as 2, 3, 5. Let's take this number. So or like take one more number 1. Okay, so let's take all the summation of all these digits. So what is this? 2 plus 3 plus 5 plus 1. 2 plus 3 is 5, 5 plus 5 is 10, and it will be 11. Okay, so the sum is coming 11 and it is not divisible by 9. Okay, hence this whole number 2351 is not divisible by 9. Okay, so this is the condition. The sum of all the digits should be divisible by 9, only then we can say that it is divisible by 9. Okay, now let's go to next one, divisibility by 10. This is very simple. The unit digit must always, only there is one condition, the unit digit should be 0, nothing else. Okay, so if the unit place contains 0, suppose 210, this is divisible by 10 because the last digit is 10. 222, this is not divisible by 10 because the unit digit contains 2, it is non-zero. Okay, it is not 0. Okay, and let's 520, so this is divisible because the unit digit is 0. Okay, last is the divisibility by 11, which is been asked. So little focus over this. Okay, there are two sum. First we have to take, okay, sum of odd places. I will tell, 1 second. Odd places, you have to take the number and have the sum of the digit which are in odd places, then you have to subtract it with the sum of digits which are in even places. Okay, array, oh, something is okay, this is up to this much. Okay, then the number which will come, that should be divisible by 11, or it can be 0 also, or it can be divisible by 0. It can be either 0 or it should be divisible by 11, then only the whole number is said to be divisible by 11. Okay, so let's quickly take one example. I will take 1331. Okay, so what are the digits on the odd places? What is odd places? This is an odd place, this is an odd place. Okay, start from here, 1 2 3 4. Okay, oh sorry, these are the odd places. Oh my god, today I am doing really very, okay, these are the odd places. Okay, and take the sum of the odd places, so 3 plus 1. Okay, and take the sum of the numbers which are in even places, so these are 1 plus 3. Okay, and what is the difference between, okay, this, it's 0. So what is the condition? It should be either divisible by 11 or it can be 0 also, then we will say that this number 1331 is divisible by 11. Okay, okay, so one of the topic is completed. Thank you so much. Let's see the another topic of HCF and LCM. Okay, so this is very small thing which we have all been taught in the childhood, but still for competitive exams you have to little bit be having refresh or brushed up in your head. So basically let's see HCF. So what is HCF? HCF is highest common factor of two or more numbers is greatest number that divides each one of them exactly. Okay, so here is a catch. So see, this will be the greatest number that divides each one. Okay, so this is this number divides both the numbers. Okay, hence this is an HCF value. It is also called the greatest common measure. Okay, so let's quickly take one example to see what is an HCF. Okay, Let me take one good example. Let me take very simple 16 and 40. Okay. So how I calculate, I will tell. So let's take 16 and 40 together. Okay. And now let's divide it by 4 firstly. So this is how much times of 4 times of, and this is 10 time. Okay. Now is there any number which is common which it can be divisible? So 2. Okay. So it is 2 and this is 5 times. Okay. Now there is no number which is common, like there is no any number except 1. Okay, except 1, but we don't take, like 1 don't have any proper significance. Okay, you can divide n number of times with n. This will be always same, 2 and 5 only. Okay, so you have to take the numbers which are here in the ladder. Okay, I said ladder, whatever you say, and take this number. So write down this number 4 into 2. This is 8. Okay, so this is the HCF of 16 and 40. So this is that number which can exactly divide 16 as well as 40. Okay, this number is that highest number which divide both the values. Okay, now let's see what is LCM, or okay, let's take LCM first. Okay, now LCM is what? It is the least common multiple. Okay, so LCM of two or more number is the least or the lowest number which is exactly divisible by each of them. Okay, so here that number will be divisible by both the numbers given to us. What was in the HCF? That this number can divide both the numbers. Whereas what will happen here? Both the number will able to divide that particular number, and that will be the lowest number in the whole series. Okay. So let's take one example. So I will take a simple example here also, 8 and 12. Okay. So if I take, I prefer this thing, ladder thing, what I say. Okay, so let's start. So 2 times this is 4, this is 6. 2 times this is 2, this is 3. Okay, very simple. So take all the numbers which are in ladder as well as which are in the last 2. Okay, take all the numbers, 2 cross 2 cross 2 cross 3. Okay, so how much is this? 2 cross 2 4, 4 cross 2 8, 8 cross 3 24. So what you can see here, these two numbers 8 as well as 12 both can divide this number. Okay, and this is called the least common multiple. This is that smallest number which this both can divide. Whereas in HCF it was, what was the condition? That the number which we got as HCF can divide both these numbers. Okay, so just vice, like just opposite things. What is HCF? What is LCM? Okay, now let's see what is the, if it's a fraction is given to you. Okay, and if it is asked you the HCF, so what you have to do? So HCF of a fraction is what? You will given few fraction values and ask to calculate the HCF of the fraction. So just take all the numerators together and do the HCF of the numerator. Then take the denominators and take the LCM of the denominators. Okay, and the value which you will get is the HCF of the whole fraction. Okay, so let me take one example and explain this. Let me take a fraction 1 by 2, 2 by 3, and let's take one more 2 by 7. Okay, very simple. So what is asked? It is asking the HCF of this fraction. Okay, so let's take the HCF of the fraction. What will be the HCF of numerator? What is in the numerator? 1, 2 and 2 are there in the numerator. Okay, 1, 2 and 2. Now let's take the LCM of the denominator, 2, 3 and 7. Okay, so what will be the HCF of this? You can do the ladder thing if you want, but this is very simple. So there is no number which all of them share as common, that is 1 only, in which this whole number can be divisible, like typically what we say. Okay, so 1 is only that number which can be there. Now take the LCM of 2, 3 and 7. Okay, so still there is no number. So what I said, to have the things which are in the ladder. Okay, so this will be only there if I have with 1, this will be 2, 3 and 7 only will be there. Okay, so take this numbers 2 cross 3 cross 7. Okay, this will be in the end of the ladder. Okay, 1 also, but 1 don't have any significance proper, so you can take this. So this is 21 and this is 21 into 2, that is 42. So the LCM of the fraction will be HCF of the fraction will be 1 by 42. Okay, very simple. Now let's go for LCM of a fraction. Okay, so it's the same thing, take the numerators and do the LCM of the numerators, take the denominators and take the HCF of the denominator. Let me take the same example, 1 by 2, 2 by 3 and the last was 3 by 7. Okay, so let's find the LCM of the fraction. Okay, we have to do the same thing, LCM of numerator. What are in the numerator? 1, 2 and 3. Okay, what are in the denominator? HCF of denominator 2, 3 and 7. So what's the LCM of this? Let's see, 1, 2 and 3. Okay, oh, there is no number which can divide all of them except 1, 1, 2 and 3. So these things are in the ladder. Okay, let's take this 1 cross 2 cross 3. Okay, what is that? It's 6. Okay, and what is the HCF of 2, 3 and 7? Yeah, the same, no number can be divisible. Okay, 2, 3 and same. Okay, and what we take in the HCF? Only the thing which are in the ladder, not in the below. Okay, so there is no number except 1. So what is the LCM? Is 6, and what is in the HCF? Okay, so very nice. So what is the LCM of this fraction? Is 6. What is the meaning of LCM? That this all numbers will be, this is the highest number which all of them can divide. Okay, so thank you so much for having the HCF LCM knowledge. Okay, like this stream and let others also know this, and please subscribe. Okay, the very beautiful topic, counting number of zeros. Okay, this is mostly asked in some of the exams, and this is sometime a must question in some of the exams. Okay, so you will be given a particular number. Okay, you will be given a particular number, a factorial of that number, and the question will ask that how many zeros are there in that. Okay, so let's go directly with an example. So if the question is given like how many number of zeros are there in 10 factorial. Okay, so how you will know that? So just have this, take 10 to the power 10 divided by 5 plus 10 divided by 5 square plus 10 divided by 5 cube, and like this. Okay, now see here a thing, what is 10 divided by 25? 10 divided by to the power 5 square, what is that? It is 25. So what is this term? This will be less than 1. Okay, so we will not take the series when it started becoming less than 1. So this will also be less than 1. Okay, This will be more smaller. Okay, so we will not take all this. We will just take this value, and how much time it is? 2 times. Okay, so just write this. That is the answer. So 10 to the 10 factorials have 2 zeros. Okay, let's take one more example, and let's take a little quite different example. Suppose it is asking me 200 and 126. Okay, in the factorial of 126, how many zeros are there? Okay, so let's do the same thing. 126 divided by 5 plus 126 divided by 5 square, 126 divided by 5 cube, 126 divided by 5 to the power 4. Okay, and this number is less than 1. Okay, by what is 5 to the power 5 cube? This is 125. Okay, so it's still, this is a number which is bigger than this, so this will be greater than 1. Okay, this is actually, okay, this will be greater than 1 if you divide. Okay, so let's just jump to the conclusion. This will be 5 plus 126 divided by 25 plus 126 divided by 125. Rest after this, the whole values are less than 1 and we don't have to take any consideration. Okay, now let's start dividing. Okay, don't worry about the remainder. Okay, first thing, if you divide 126 by 5, what is the how much times it will be? 2 times is 10 and 26, so 5 times is 25 and the remainder is 1. Don't care about the remainder. Okay, so what is the value coming here? This is, you can take it 25 point something something, remain, leave that. Similarly, this will be divided like 4 times. Okay, oh sorry 5 times. I should do the things, I think so. Okay, for more clarity. Okay, this is 5. Similarly, this is approximately 1 point something. Okay, now take these values, 2, 25 plus 5 plus 1. Okay, add this all, this is 31. So in 126 factorial, there are 31 zeros. Okay, that's it. That's a very simple trick. Just you have to divide it with 5 square, 5 cube, or 5 to the power 4. Continue, go with that and just have the number divided. Don't go for the remainder thing, it's okay. Just go for the quotient. Okay, put the values, take the values and add it, and that is the number of zeros which is coming in the factorial. Okay, thank you so much for having that counting numbers of zeros. Now let's go to the next topic of factors of composite number. Okay, so this is also asked in exams, that you will be given a particular number and it will be asked what is the how many factors are there of that particular number. Okay, for this first you should know what is a composite number. So let's quickly brush up composite number. Composite numbers are the numbers which can be factorized into prime factors. Okay, or composite numbers are those numbers which are not prime. Okay, they are made from prime numbers. Prime numbers are what? Which cannot be divisible, which cannot be divided by any other number except themselves. Okay, so it's like a number such as 8. Okay, this is made by 2 into 2 into 2. Okay, these two are prime. 2 cannot be divided by any other number except 2. Okay, don't argue with 1. Okay, we don't consider also for that prime number criteria. Okay, so by these prime numbers, this 8 has been made. It's a composite. Okay, composite of all these prime numbers. Okay, so in the question it is asked that how many factors are there of a composite number. So let's take this example only, 8. Okay, so let me write it again. So it is something like this, 2 to the power 3. Okay, now take this value and add 1. 3 plus 1, that is 4. Okay, hence I can say that number of factors of 8 are 4. So there are 4 values which are the factors of 8. Okay, factors of 8 is 4. There are 4 values. Let's take a little different example. Let's take a number such as, if I go for 27, it's 3 to the power cube. Okay, let me take one more example. Okay, let's take 45. Okay, so if in the question is asked how many factors are there of 45. Okay, so first, how 45 is been formed. 45, go for this ladder method 5 times, this is 9, go for 3. Okay, not more than that, 3 will 1 and nothing more than that. Okay, so what are the numbers, just take that. So 3 into 3, I am starting from smaller, into 5. Okay, what this can be written as 3 square into 5. Okay, what is the power of 5? 1. Take this value, take this value, add 1 to both of them and multiply. Okay, this will be 3 into 2, that means 6. Okay, if such numbers are there, you have to just add 1. Okay, so this numbers who's there, just add to the power 1 to them and multiply. So there are 6 factors of 45. Okay, what are they, by the way? If someone asks, 1, you can just see from here only, it's not a big deal. It's 3, it's you can take both this number together, it's 9. You can take both this number together, it's 15. Oh, by the way, 5 also, 15, and then 45 itself. Okay, 1 2 3 4 5 6. I'm right now not good with this pad, but I'll try to. Okay, so these are the 6 numbers which are the factors of 45. Okay, thank you so much. Okay, the ending of stream, please like the stream, and we will every day upload different questions also. We will further take the question, we will take see your comment section also. What are your comments? In the comments you can ask doubts and different things, and please like the channel, subscribe, and get up to dated for, because the exams are coming and we will complete first the aptitude series. Here only you will see cyclicity have been over, divisibility, HCF and counting of numbers. We will go for further for percentage, ratio and proportion. We will complete every day, try to complete max to max topics and cover each of them before the exams. And okay, thank you so much. Please like the stream. Okay, thank you so much.